Okay, so the first thing we're going to start off with is domain, right? It's one of the first things we looked at in this school year. And remember, domain refers to your set of all x's in an equation. So if we look at this equation, right, we always assume that every equation starts off from, well, basically from negative infinity to positive infinity as its domain. And the equation itself, or the function, is going to restrict its domain in some way. For example, we have this square root right here. And as you all know, what we can never have inside of a square root, or under a square root, better said, is a negative number, because otherwise you get imaginary numbers. So the number one thing that you can't have is a negative number in here. So if I try to put in negative 5 plus 5, well, that just gives me 0, and the square root of 0 is still 0. So that's okay. I can have negative 5 in there, but I can't have something like negative 6. Negative 6 plus 5 is negative 1, and that would make that imaginary, so we can't have that. In other words, we can say that x has to be greater than or equal to negative 5. And so that's going to be the first requirement for my domain. The other requirement when it comes to this function is that since we are dividing, and one of the things that we can never do is divide by 0, we have to make sure that this denominator does not equal 0. So it cannot equal 0. The two numbers that would make this 0 would be negative 9 and a positive 7. So x cannot be negative 9 or positive 7. So when we look at our answer choices, well, we know for sure it's not going to be D. And we know for sure it can't be 0 because, you know, that would include 7. 0 to infinity because that would include 7. So we are left with two answers, C and B. B says from negative infinity all the way to negative 9. Well, we already said that x has to be greater than negative 5. So something like negative infinity or negative 100 would not be included in there. So it's not going to be B. And then C is going to be our answer. We have negative 5 to 7, and then we skip over 7, and then we go to positive infinity. Yeah, so that's correct. We're going to be larger than negative 5, and we're going to skip over 7. Negative 9 is not included in here because negative 9 is less than negative 5, so it's already not included. So our answer is just going to be C. Moving on, we have this next equation. This next question is asking us the difference between an odd function and an even function. So first of all, let's go ahead and remember what those mean. So we're going to start off with even. So an even function is going to be something like y is equal to x squared, which is symmetrical by the y-axis. All right? An odd function, on the other hand, is going to be something like y is equal to x cubed, and it's going to be symmetrical about the origin. Now, what does that mean? Symmetrical about the origin just means that it looks the same right side up and upside down. In other words, if I were to turn this graph upside down, it would still look the same, you know, going down on the left and then going up on the right. It should go exactly through the origin. I apologize about that. It seems like I was a little bit off on that. There we go, that looks a little bit better. So, yes, ladies and gentlemen, that's what an odd function would be. Now, notice how even functions just so happen to have an even exponent, and odd functions just so happen to have an odd exponent, and that's by design. So that's another way that you can check whether they are even or odd. When we look at these, we notice a couple of things. Number one, if you were to graph this, because you are going to have a graphing calculator on your midterm, you were to notice that this function would be symmetrical by the y-axis, but you also notice that, hey, guess what? It also has an even degree. And this one, you would notice that it has an odd degree, and if you were to graph it, you would notice that it would be symmetrical by the origin. So the answer to this one is going to be even, and the answer to this one is going to be odd. Number 4 asks a very similar question. It's not the exact same question, but it's still asking a question with the same ideas. And number 4 is basically telling giving you the 12 basic functions, and it's asking which four functions look the same when they are turned upside down. In other words, you're looking for the odd functions. So we need to figure out which one of these functions are odd. Based on the first unit where I had you go over the 12 basic functions, you should have a basic idea of what these functions look like. So y is equal to x is basically a linear equation, straight line. Y is equal to x squared, that's a parabola. Y is equal to x cubed is this line. Y is equal to the absolute value of x, looks like a v. Y is equal to 1 over x is this one, the one with two asymptotes, rational function. Y is equal to e to the x is the exponential function, so that is an asymptote, and then it goes straight up. Y is equal to the square root of x, starts at the origin and then goes up and to the right towards infinity. Y is equal to the ln of x, looks very similar to the square root of x, but it actually starts at an asymptote and does not cross through the origin, but it still goes up and to the right. Sine of x is a sinusoidal wave, so as a wave, it's going to look a little bit something like this, and this one actually crosses through the origin. All right. Cosine is also a wave, but it actually does not cross through the origin. It crosses through 1. So it looks a little bit like that. And then finally the integer function. Next, the integer function is also known as the step function. Looks like a couple little steps. And finally, the logistics function. The logistics function has two asymptotes, and it looks a little bit something like this, with, once again, those two asymptotes going through there and through there. Okay, now that we have that drawn out and we basically know what the shape of these are, we can actually go ahead and answer the question. Now, if you are not sure about what these shapes are, once again, you will have a calculator with you, so you could take your time and just graph each one of these individually and, flip the calculator upside down on your desk. And you could do it that way. But from here, we can actually tell that this one would look the same upside down, this one would too, this one would too, and finally sine of x would too. So that's 1, 2, 3, 4. Your answer is going to be B. Which of the following, if the following is a polynomial function, state its degree and leading coefficient. If not, then state this fact. Okay, so number 1, is it a polynomial function? I don't see any x's in its exponent. I don't see it being divided by anything. I see it in polynomial form, with a coefficient, the variable, and then raised to a power. So yes, this is a polynomial function for sure. So D is not going to be your answer. Its degree is always the highest exponent, so it looks like that's 4. So C is not going to be your answer. And then the leading coefficient is always with the leading term, which goes with the degree. It doesn't matter that it's not in standard form and it's not in decreasing order. They're trying to trick you by telling you, oh, it's going to be 3. But that's not the case. It's actually going to be 19. Okay, next one, it's telling us to go ahead and find the axis of the graph of this function. Now, by axis, what they actually mean is the axis of symmetry. All right, so they mean the axis of symmetry. In other words, what line can I use to cut this equation straight in half? So let's go ahead and first and foremost, this is a transformation of a quadratic equation. So it's going to be 1, 2, 3, 4 to the right. We have x minus 4, that means 4 to the right. Remember, when it's inside parentheses, we basically go the opposite way of what we might think, so 4 to the right. And then that minus 4 gives us 4 down, 1, 2, 3, 4. And all of you should know what a quadratic equation looks like. It's a parabola. And so the axis of symmetry, the line that's going to cut this in half, is going to go right through the middle of it at x is equal to 4. X is equal to positive 4. There it is. Describe the end behavior of the polynomial function. Okay, we can do that. we got to know a couple things. Number one, you could come up with the little chart that I showed you guys last time, the one that says even, odd, positive, negative. Or you could go ahead and graph this, right? But based on the chart, my knowledge of the chart, and if you don't know the chart, you need to go back and look it up. But basically it says that when you have an when you have an odd function, meaning that the degree is odd, then you're going to have a graph going in opposite directions, right? Either up, down, or down, up. And since this one is a positive function, in other words, my leading coefficient is positive, right? That x is positive. You're going to have it going upwards in a positive direction. So even though this isn't exactly my graph, I know that this is the general shape of it, right? It's going down on the left and up on the right. So now we go back to our question. And it says, by finding the limit of my function of x as x is approaching infinity. That's over here on this side, positive infinity. So when it's approaching positive infinity, my graph is going up towards positive infinity. So it's not negative infinity, not negative infinity. There's these two. And then when it's going down towards negative infinity, well, it's going down towards negative infinity. So it's not going to be this one. It's going to be C. Find the zeros of the function. Okay. Finding the zeros of the function can actually be pretty easy depending on the question itself. This one is extremely easy. This is one that you've been doing since Algebra 1. Right? You're asking yourself, okay, what two numbers, when I multiply them, give me 5? Well, really, I only have 1 and 5. And when I add them, give me negative 4. Okay, so since this is a negative 5, it's got to be either negative 1 and positive 5 or negative 5 and positive 1. Since I need to add them to get to negative 4, it's going to be this pair. So we have x minus 5 times x plus 1. Don't be so quick to go ahead and choose A, because that's not your answer, even though we have negative 5 and 1 here. We need to equal each one of these to 0, so this is equal to positive 5, right? If I plugged in a positive 5 there, 5 minus 5 gives me 0. And here we're going to have negative 1. And so this will actually be our answer, which is C. This you would do the same thing. Well, actually, for one like this, I would actually recommend that you graph them. If you look at your answer choices, they're all going to be real numbers, so you will actually see them on the graph as x-intercepts. So go ahead and graph it, and then you would use menu, and you'd go to analyze, and then you'd click on finding your zeros. And then from there, the graph is the graphing calculator is actually going to tell you exactly where your zeros are. So there's no need to stress about a problem like this. Okay, now we're working on division. So it's telling us to divide x squared minus 2x plus 7. We're going to divide it by x minus 3. So they're asking us to divide x squared minus 2x plus 7 and divide it by x minus 3. So we're going to go ahead and just focus on the first terms. X and x squared. X times what would give me x squared? Well, x. So x times x gives me x squared. And I need to go ahead and distribute that to that negative 3 as well, which gives me negative 3x. When I go ahead and subtract these two, I get negative 2x minus negative 3. That minus negative 3 makes me want to, or makes it so that I have to add a positive 3 to this negative 2x, right? These are going to cancel out. So here I'm going to actually say negative 2x plus positive 3x, which gives me 1x plus 7. From this point forward, I can say, okay, well, x goes into x just positive 1 time. So I go ahead and distribute x minus 3. Once again, I am subtracting a negative, which gives me a plus positive, so 10 would be my remainder. Now that I have this, to put it in polynomial form, I would go ahead and multiply this times this with the addition of this. So my answer is going to be D, I believe. Okay, now this one says, using the given zero, find all other zeros of f of x. So we have x to the fourth minus 12x squared minus 64. Okay, now in this case, what you guys would want to go ahead and do is use that little math trick, a is equal to x squared, where you replace your x squared with another variable so that you can turn this into a quadratic equation. So you say, okay, well, this is a to the second power minus 12a minus 64. And now you can actually go ahead and factor this out a lot easier. Okay, so you're looking for two numbers that when you multiply them give you negative 64, and when you add them give you negative 12. So if you're having trouble, we can list those out. We got 8 times 8, right? We got 1 and 64. We got 2 and 32. Then we got 4 and 16. And well, look at that. Since this is negative, one of these has to be negative. If we make that negative 16 negative, we make that 16 negative, then negative 16 plus 4 would give me negative 12. So I can actually say, well, this is going to be a minus 16 times a plus 4. We go ahead and turn this back into my x squared, and we get x squared minus 16 times x squared plus 4. And this is actually a difference of squares. Difference of squares, ladies and gentlemen, remember you take the square root of x squared, which is just x, and the square root of 16, and you go ahead and add, and you subtract. And this is the factor that you have. And for a sum of squares, you basically do the exact same thing, except that you're going to have to add an I. So this is going to be the square root of x squared is x, and then minus the square root of 4, which is 2, but because this is a sum of squares, we're going to add that I. And then, of course, plus 2i as well. So here we have our 4 zeros, right? X is equal to negative 4. If I solve for x, this will be negative 4. X is equal to positive 4. X is equal to positive 2i. And x is equal to negative 2i, which would be b. Sorry, can't see that. B. Negative 2i is already included there, so they're only going to give us 3. Number 12 is very similar in concept. This is actually using sum of squares. You see how this right here looks very similar to this over here. So what we're going to do is we're going to go ahead and say, okay, well, we know that this is a sum of squares. So first of all, it can't be a because that's a difference of squares. So we're going to eliminate that. And then, okay, we need to find the zeros of it. So the zeros are going to be positive 5i and negative 5i. So it's not C. It's not C. Oops. Sorry, it's not B. It's just going to be D. This next one says to find all rational zeros. So in this case, we're actually going to go ahead and graph this. Oh, man. Okay, we can't graph that there. So we can go over here. Let's see if we can't. Okay, we have 4x raised to the third power minus 8x raised to the second power minus x plus 2. Okay. Oops. So using Desmos, I was able to graph this, and you guys can either use, well, you guys will have your regular graphing calculator the day of the test. For practice, you guys can use desmos.com if you'd like. And you guys can actually see that Desmos gives us our points, right? So we have negative 0.5, negative 1/2, positive 1/2, and positive 2. So we go back to this, negative, positive, and positive 2. That would be our answer. Yeah, this has a negative 2, so it's not it. This doesn't have the halves, and this doesn't have the halves. Okay. For the given function, find all asymptotes of the indicated type if there are any. So now we're getting into rational functions. Rational functions, we have basically 3 types of asymptotes that we can look for, which are vertical, horizontal, and slant or oblique, right? Which also, I guess they kind of fall under the horizontal ones. But basically, there are 3 types of rational functions you can have. There are top-heavy functions, there are bottom-heavy functions, and there are functions that are the same. What I mean by top-heavy, bottom-heavy, and the same is I'm referring to their degree. If you look at the degree, this has a degree of just 1. This has a degree of 2 because of that 2 there. So we're looking at the leading terms in this case, right? So the leading term has a degree of 1. Leading term in the denominator has a degree of 2. So this is going to be a bottom-heavy function. Okay, so this is a bottom-heavy function. Now, if you don't remember what a top-heavy function does, when they're top-heavy, you have to divide the polynomials. And this is going to lead to slant/oblique asymptotes. Okay, so you're going to have to divide the polynomial. We'll do that a little bit later down in the test. For when they're the same, you actually divide the LCs. You divide the leading coefficients. So you would divide whatever the leading coefficients are, and that would be your horizontal asymptote. For bottom-heavy functions, these are the easiest ones. It's always just y is equal to 0. So there's actually nothing mathematical to work out. You just need to remember that rule. Y is equal to 0. 15 goes ahead and says, okay, if we have y is equal, so we're trying to evaluate the limit. My bad. We're trying to evaluate the limit. The limit of my function of x as x approaches 5 from the positive side. So we count 1, 2, 3, 4, 5, exactly where I thought it would be. All right, so we're trying to figure out what happens as my function approaches that from the positive side. So this plus right here, that plus means from the positive side. The positive side, well, if that's negative infinity over here, positive infinity has to be over here. There we go. So in other words, if I start over here and I go towards what? Towards 5, what is happening to my function? Well, the closer I get to 5, if I follow the curve, I'm going down towards negative infinity. A would be my answer. Next one says, for the given function, find all asymptotes of the type indicated if there are any. Now they're asking for vertical asymptotes. So for vertical asymptotes, you actually go ahead and equal the denominator to 0. So we go ahead and take x squared minus 9 and equal it to 0. It's actually very, very simple to do because this is a difference of squares, right? Difference of squares. So we have that x squared minus 9, which is 3 squared. So we take the square root of x squared, which is x, the square root of 9, which is 3. So we take x plus 3 times x minus 3. And then when we solve for the zeros of these, that's just going to be x is equal to 3 and negative 3. There we go. B. For this next one, they're asking us to find the intercepts and to graph the function. Okay, I'm pretty sure we can do that. Okay, so first of all, to find the intercepts of, to find the x-intercept. The x-intercept, we have to equal the numerator to 0 for the x-intercept. But if you look at this numerator, that numerator is just negative 4. There's no way to just magically make it 0. All right, there's no variable there, so there's going to be no x-intercept. And if you look at all your answer choices, all of them have no x-intercept. So you know that for sure has to be true. Next is the y-intercept. And for a y-intercept, what you do is you equal x to 0. So we're going to basically take this, negative 4 over x minus 6, and we're going to equal the x to 0. So negative 4 divided by 0 minus 6, so negative 4 over 6, which is, over negative 6, which is just simplified to a positive 2/3. So since it's positive, it can't be A, can't be C, it's got to be one of these two. Notice how they're exactly the same except one is shifted to the left, one is shifted to the right. If you go back to our equation, we notice that that says x minus 6. And you can think of this denominator as the parentheses, right? What did I tell you happens whenever it's in parentheses? You go the opposite way of what you would think. So if that is negative 6, then it would not go to the left. It would actually end up going to the right. And so D is your answer. All right, for the given function, find all asymptotes of the type indicated, if there are any. Now we're working with slants. Okay, just like I promised, we would be finding slant asymptotes. So slant asymptotes, we use long division. And what we're going to do is we're going to go ahead and take this x squared minus 3x plus 2 and do exactly what my equation is telling me to do. It's basically telling me take this divided by this. So we're going to do that. Divide it by x plus 2. So we're going to go ahead and say, okay, x times what gives me x squared, x. We go ahead and distribute that. We get x plus 2x, and then we're going to subtract. X squared and x, sorry, this is x squared. X squared and x squared are going to cancel each other out, and then I have negative 3 minus 2x. So negative 3 minus 2 gives me negative 5x plus 2. Brought that down. And we go ahead and say, okay, x times what gives me negative 5x? That's minus 5. And we'd get minus 5x. We'd get minus 10. Subtract these two. These are going to cancel out. And minus a negative 10 actually means to add, so I'm going to add that there. That's my remainder. But honestly, the remainder doesn't matter. That's what we care about. Y is equal to x minus 5. Okay, awesome. So for this next part, we're going more into exponential functions now. So exponential function, state its initial value and its base. Okay, so first of all, this is an exponential function. It's got an x as an exponent. So exponential functions have variables as exponents. You shouldn't have pi or 2 or a constant or anything else up there, right? Next thing we're going to determine is its base. Its base is whatever is being raised by the variable. So we have 3 to the x, so 3 would be its base. So if we look at this, this has a base of x. That's not it. That's not it. B is not it because it has a base of negative 99. It makes no sense. This is an exponential function, so this is going to be your answer. And then obviously negative 3.3 is going to be your initial value. It's whatever comes in front of the base. This next one says to compute the exact value for the function for the given x without using a calculator. So this one is without using a calculator. We would go ahead and say, okay, so 3 to the 1 minus x for x is equal to 3. Okay, so 3 to the 1 minus 3. That's equal to 3 to the negative 2. Now, a negative will turn this into its reciprocal, 1 over 3 squared, which is equal to 1 over 9. And my answer would be here. Okay, this one says evaluate the logarithm. You're going to have a calculator with you, and again, I'm not expecting you guys to do these logarithms without a calculator. You could use change of base formula, but don't worry about it because your calculator actually is able to do it. So if I go to a calculator that can go ahead and do that for me, let's go ahead and use Wolfram Alpha. We can actually go ahead and type that in. We'll type the log base 8 of 32. And this is why it's super important to know how to say logarithms, how to read them, how to say them out loud. Log base 8 of 32. So the calculator understands me. The exact result is 5 over 3. Or you might get this in your calculator if you type it in, 1.6666667 or something like that. But we know that this calculator is telling us that our answer is going to be 5 over 3. Next, we get into a little bit into logarithms. Assuming all variables are positive, use properties of logarithms to express as a sum or difference. So we're basically trying to expand. Okay. So remember, when you are multiplying logarithms, you can go ahead and separate them and add their two logs. When you're dividing numbers inside of a logarithm, you can separate them and subtract their two logs. So we're going to end up with something like log of x to the 6th power plus the log of y to the 7th power minus the log of 5. Okay. And because of our power rule, we can actually take these exponents and bring them to the front. So we get 6 log of x's, sorry, no more to the 6, plus 7 log y, and all these are log base 5, sorry. They should all have a base of 5. Minus log base 5 of 5. The answer to 22 will be C. Now 23, it says solve the equation by changing it to exponential form. Okay, we can do that. We'll pick a different color, orange. And it says log of x. Now since we know that this is common log, we're going to go ahead and add that base in there. It's going to help us out later. Okay, so we have that, and what we're going to do is we're going to turn it into exponential form to solve for x, right? So exponential form says 10 to the third power is equal to x. 10 to the third power is equal to x. So not that, not that, not that. Here we go. X is equal to 10 to the third power. Okay, so now we're going to go ahead and work with more logarithm rules. We have log base 10, because it's common log, of the square of the fifth root of x over y. Okay. So remember, sorry, let's use another color. We'll go with purple. So for this case, we're going to say, okay, so if I have log of x over y, I'm going to want to raise this. I'm going to want to change that to the fifth power. And I'm going to want to change it to 1 over 5. Why? Because the fifth root, in other words, x to the a over b, is equal to the b root of x to the a. You see how that fifth root became my denominator there? X to the a over b is equal to b root of x to the a. So that's why we did that. Since we do have power, we can go ahead and bring it to the front. So we have 1/5 log of x over y. Okay, we could honestly say this whole thing divided by 5, or we're just going to leave it like that for now. And because they're being divided here, we can go ahead and say, okay, 1/5 of log of x minus 1/5 log of y. That looks like A is going to be my answer. Yeah, there we go. We have 25. Okay. So 25 is actually asking us to combine them as a single logarithm. So again, if we're subtracting two logarithms, then we can go ahead and divide their arguments inside. So log base 6, they have the same base, of 7 divided by x. Log base 6 of 7 divided by x. Not that one, that has the wrong base. No, we're not subtracting, we're dividing. 7 came first, so 7 is the one on top, not the one on the bottom. Here we have the exact same thing, right? But now since we're adding, we're actually going to go ahead and multiply them. So log base b of x is equal to, plus log base b of y. Okay, we need to have a base b, not 2b, not 2b, and we're not adding them. It has to be log base b of x times y. All right, so now we're getting into financial calculator stuff. 27 and 28. It says find the future value accumulated in an annuity after investing periodic payments of $550 for 7 years at an annual interest rate of 6% with payments made and credited 4 times per year. Okay, so we're going to need to find a couple things. We're going to need to find our N, we're going to need to find our I, which is our interest. We're going to need to find our payments, and I think that's going to be it. And then future value is going to be the final thing that we find. So N is going to be 7 times 4 because it's happening 4 times per year for 7 years. So 7 times 4 is going to give us 28. Our interest rate is going to be 7 divided by 4. Right, so let's quickly do that. 7 divided by 4. Okay, so we get 1.75%. Remember, this is percent. This isn't in decimal yet. We may need to change it. and the payment is going to be $550. And if it's an ordinary annuity, which it is because it hasn't told us anything else, then the payments are going to be made at the end of the month. That's for all ordinary annuities. Okay, now we go to our financial calculator. If you have a calculator like a Wolfram Alpha calculator, then you would go to you would go to New Doc. Then you would go to Add Calculator. Then you would go to Menu, then Finance, and then Finance Solver, which is going to pull up a finance solver that's not going to look exactly like, but it's going to look very similar to this. Okay, present value is currently going to be 0. Future value is what we're looking for. Number of periods, this is going to be your n. So it's that 7 times 4, which is going to be 28. Payment amount, we're going to say we're paying $550. And the interest rate per period, that's that 1.75%. They're asking for it in percent right here. You see how they're asking for percent? So we're going to compute future value. Future value is going to be, oh, I see what I did. My interest rate is actually 6. Sorry, I made that mistake. I thought it was 7. So it's good to see your mistakes. Okay, so this is going to be 6 over 4. That's completely my mistake. So it's going to be 6 divided by 4, which is going to be 1.5. All right, we go back. And we're going to have interest rate of 1.5 instead. And now we can come, there we go. So our answer is going to be A, which matches up to what we got. My mistake, but we fixed it. We can move on to the next one. It says find the amount accumulated after investing a principal P for T years at an interest rate of R. So in this one, there's no payment. No payment. You just have a lump sum and you're investing it for a certain amount of time. Okay. So it's compounded annually, so once per year for 11 years at 4%, and it's $1,000. So we go back. We say, okay, present value is going to be $1,000. Okay. So, oops, my bad. Future value is going to be, well, we don't know that yet, so we're just going to put it at 0. Number of periods is going to be, 11. Payment amount, that's going to be 0.0. And interest rate per period is going to be simply 4%. And we're going to calculate the future value. So the future value is going to be 1,539.45, which is going to be B. And there we go, ladies and gentlemen. That's the whole entire midterm review. Let me know if you have questions. Please make sure you study, and I will see you guys in class.